All right, welcome geometry. This is 11.6, surface areas and volumes of spheres. So you may notice that we have a lot of terms that we need to get familiar with. So if you need to pause the video to kind of read through them and copy them down in your notes, go for it. We're going to start off with a sphere. A sphere is the set of all points in a space equidistant from a given point called the center. And the center, by extension, is the point which all points on a given sphere are equidistant from. The same distance from that one point. The radius is a segment that has one endpoint at the center and the other endpoint on the sphere. A hemisphere is just half of the sphere. Circumference. Now, we define circumference in terms of the sphere. The circumference of a great circle is the same as the circumference of the sphere. So once we know one, we know the other. But you might be asking, what's a great circle? A great circle is the intersection of a plane and the sphere in more than one point, whose center is the center of the sphere. Now, what that means is if I were to draw a simple plane, I'm going to try my best here. Again, I'm not an artist. That is on the eraser function. I want the markers. Let's try that again, shall we? So I'm going to draw a little plane here. So here's my plane. It doesn't look pretty, but there's my plane and it intersects my sphere. And there it goes right through the center. That's what we call a great circle. And the circumference of that great circle, which is again 2 pi r, or pi d if they give you the diameter, that's the same as the circumference of the entire sphere. Now, I'm going to show you something about the radius. They give you a radius here. We just call it r. So it has one endpoint at the center and the other point on the sphere. So we're going to mark that distance just like that. That distance is the same as this distance, which is the same as this distance down here, which is the same as this distance right here, and down there, and over here, and even over here. All of our points are on the sphere. There's no points inside the sphere other than the center. It's like a ball. So hopefully that helps you out a little bit. We're going to jump right in and give you a formula. We're going to give you the formula for a surface area of the sphere first. Surface area is 4 pi r squared. Why times 4? Because we know the area of a circle is just pi r squared. Look at the diagram of the baseball on the left. This kind of outlines a sphere. There are 4 circles on there, hence the 4 pi r squared. So let's get some practice using that formula. 4 pi r squared is the surface area. Let's find the surface area of number 1. Leave our answer in terms of pi, and we'll go ahead and round it to the nearest tenth. Here, they give us the diameter. It goes all the way across. The radius is still halfway across. That doesn't change. So that means my radius is 5 meters. So my surface area, once again, 4 times pi r squared. So surface area is 4 times 5 squared times pi. 5 squared, that's an easy one. We know that one. That's 25. So we got 4 times 25 pi. In terms of pi, I've got 100 pi meters squared. So that's my surface area in terms of pi. Rounded to the nearest tenth, you should get hopefully around 314.2 meters squared. So I would like for you to do number 2. I'll scroll up here so you can kind of read it. You approach it the exact same way you did number 1. So go ahead. All right, hopefully you've had some time to do number 2. I'm just going to breeze through this one. And I'll kind of briefly explain some things as I go. My radius is 7 because they give us the diameter again. Surface area 4 pi r squared. 4 times 7 squared times pi, which is 4 times 49, which gives us 196 pi inches squared. And rounded to the nearest tenth, 615.8 inches squared. Hopefully you got the same thing that I did. If you need further explanation on that one, let me know. Here we got number 3. This one's a little bit tricky, but we're going to go ahead and walk through it. Earth's equator is about 24,902 miles long. What is the approximate surface area of the Earth? Now, remember, the equator is like the belt of the Earth. We can think of this as the great circle of the Earth. And what we know about the great circle is that its circumference is the same as the circumference of the sphere. So I'm going to start by copying down c equals 2 pi r. That's the formula for the circumference. We want to find radius. So here we go. 24,902 equals 2 pi r. Divide each side by 2 pi. I'm going to leave it as the symbol, but we are looking for a number. So take 24,902, divide it by 2, and then divide it by pi. Excuse me. I would get 3,963.3 miles. Here is how I would approach doing this one so I can get the most accurate answer. We know surface area, 4 pi r squared. Nothing new. Take this decimal and square it right away. So 3,963.3 squared pi. I would leave it as that long, ugly decimal and then just square it. And once you've got it squared, multiply it by 4. And you get 62,830,239.1 pi miles squared, because we are talking about miles. Now that's the answer in terms of pi, because I still have my pi symbol even though I have a decimal. If I want to find it rounded to the nearest tenth, take that big old decimal, multiply it by pi, and this is going to be a big one, so bear with me. It's 197,387,017.5 miles squared. Kind of big, don't you think? So that wraps it up for surface area. We're going to move on to volume. Just fair warning, volume formula looks a little bit wonky. So here we go. Volume equals 4/3 times pi r cubed to the third power. So this is the formula we are going to use for volume. All right, number 4, find the volume of each sphere in terms of pi and to the nearest tenth. Here we go. They give us the radius. Awesome, 6 meters. Copy down your volume formula. V equals 4/3 pi r cubed. We know the radius, it's 6. So we got 4/3 times, I am getting ahead of myself. Let's try that again, shall we? Times 6 to the third times pi. Okay. Now, let's break it down even further. 4/3, 6 to the third is 216. Here's how I would go about plugging this into your calculator, because you might be concerned about that 4/3. This is what I would do. I'm going to write it up here. Take 216, multiply it by 4, and then you get an answer. And then you divide it by 3, and that'll get you the answer in terms of pi. And what I got is 288. So 288 pi cubic meters. Because this is volume we're talking about this time. Rounded to the nearest tenth, it's 904.8 cubic meters. And there we go. So those are the answers for what number was that for? Scroll back down in case you need to get those copied down quick. Number 5, I want you to you're going to approach it the exact same way we did number 4, so give it a go. Okay, hopefully you've had some time to do number 5. I'm just going to breeze right through this one. Here's my radius. So it's 12 millimeters. Volume is 4/3 pi times the radius raised to the 3rd power. 4/3 times 12 to the 3rd times pi. Big number here coming in. It is 4/3 times 1,728 times pi. In terms of pi, 1728 times 4 divided by 3, you get 2,304 pi millimeters cubed. Rounded to the nearest tenth, your volume is approximately 7,238.2 millimeters cubed. So that's it for today's lesson. You should have a worksheet coming in to Google Classroom soon if it's not there already. If you've got questions, shoot one of the geometry teachers an email. Otherwise, thank you guys for tuning in. We will see you next time.